Hello, one and all. If you're tuning in live, thanks for making the time in your busy day. If you're watching this later on YouTube, thanks for stopping by. However you're watching, welcome to Postmedia's Driving into the Future Roundtables, where we'll discuss, well, the future of driving. I'm David Booth, and I'm the senior writer for Driving.ca. Today, we're going to be talking to our panel of experts about a sustainable model for our future mobility needs. Sustainability is absolutely crucial for the automotive industry as we try to reduce our carbon footprint. And it's certain that electrification will play a huge part in the cars of the future. But what does a fully sustainable mobility future look like? Will it be completely gasoline free, or will there be plug-in hybrids and regular hybrids in the mix? Is battery technology being developed that can see us through this sustainable future? And just as importantly, will our infrastructure, both the power generation and the power distribution networks, be up to the world, comprised entirely of zero-emission vehicles? To help us find out what the future holds, we're talking with Olivier Loedel, head of Electrification Ecosystems at Volvo Cars, Robert Barrosa, Electrify Canada's Senior Director of Sales and Business Development and Marketing, Frederick Prigge, Director of Research, Development and Deployment for the Innovative Vehicle Institute, and Karim Zaghib, Professor of Practice at McGill University and the former Chief Technology Officer at Hydro Quebec. Before we start, let me remind viewers that I will be trying to get to your questions at the end of this discussion. And gentlemen, as I've discussed before, the questions in this week speak to a consumer both eager but wary of completely electric future. Okay, first question is to Olivier. Olivier, Volvo recently announced that all its cars will be electric by 2030. What does that mean? Are you saying that only one version of each model will be available and it will only have a battery powered option? Or are you saying there'll be only electric powertrains with some of them will be hybrids? And by electric, do you mean only battery powered EVs, or are you including plug-in hybrids as well? What exactly is Volvo's intent here?
Basically, what we have indeed recently announced is by 2030, we will be only selling fully electric cars, meaning that by that time, we would have removed from our portfolio any cars with an internal combustion engine, including hybrids. So literally only fully electric cars.
So no plug-ins, no hybrids, simply electrics.
By 2030, fully electric only, yes.
That's very brave, very good. Elon Musk would be very proud of you. Okay, Frederick, you've worked with electric vehicles of all kinds for quite some time now. The question I have for you is, is Canada really ready to go all electric? Is our transportation future really going to be all battery powered, or will there be place for plug-in hybrids? Will there be any place for hydrogen and fuel cells? Where do you see us, say, in about 10 years?
Well, Canada is a very diverse country. Let's start with that. If you live close to the border, where the majority of the population is, you can probably get by with a pure EV, with a battery-powered vehicle, just fine today, even with today's range. If you live in a place a bit more remote, or even in the territories, no way right now you can survive with a BEV, and probably not in the next decade. So there is a place, at least in my opinion, for plug-in hybrids or even regular hybrids for specialized applications. And dare I say, some needs, a full percentage of Canadians should still stick to a very low pollution gasoline-powered car. It's not a big percentage, but some people will still be better served by that in the mix, at least for a 10-year period. I can't say for such a long term. If you want to see into the future, ask Karim. He's got a very good insight on what's happening in the next decades. But for this current decade, I think battery electric is going to be the choice for a majority of Canadians, but certainly not all of them. Congratulations to Volvo for their commitment. I think in the long term it will pay off, but for quite a while there will still be plug-ins and probably even regular hybrids out there. On the other topic of hydrogen, I'm not a big fan. Sincerely, I'm not a big fan of hydrogen. If you're going to currently, you have to know that pretty much all the hydrogen available out there is made with natural gas. So you're using methane and you're splitting it, removing CO2 and keeping the hydrogen portion. You're generating a lot of CO2 when you're making that hydrogen. Green hydrogen is possible. You can make hydrogen out of electricity. It's totally possible, but it's less efficient than just charge a battery. So you're leaving a bit more of that energy on the table. But the end result is that you have sluggish vehicles that are extremely heavy, even heavier than a battery powered vehicle. And this is a topic that's not often discussed. Uh, I'm asking you viewers, just go look at the specs of a Toyota Mirai and compare it to a Tesla Model 3. It's completely different world in terms of performance, but they both have the same range and they both weigh about the same, or the Mirai is even a bit more heavy than the Model 3. So those are two fully developed vehicles. Those are not prototypes. Those are fully developed and produced vehicles. So it gives you an idea of where hydrogen is going. We should keep that fuel, which is incredibly energy dense, for two type of applications. Applications where you have to go a very, very long distance. Let's say a train that has to cross Canada. That would be a very good application, or an airplane. Those are good applications for hydrogen. Or anything where you need super fast fueling. Nothing beats hydrogen in terms of joules per second you can inject in a vehicle. No fast charge infrastructure can come close to that. So let's keep that precious fuel for applications where it's really required, and everything that can be solved with plugins or pure battery powered vehicle, let's use that, which is much simpler and still evolving technology. But that would be my view of the future.
That well, we can all go home now. You've just answered all the questions.
Sorry.
Thanks very much, Robert. Volvo's ambitions are huge, and they're not the only one. There's lots of other car companies that are making similar pledges, not all the same year as Volvo. What is it going to take to be prepared for this future? Will our charging infrastructure be able to handle our day-to-day driving needs? And what about our peak day travels, like Labor Day, when it seems like absolutely everyone's on the road? Will the charging infrastructure be up to a peak load like that? Or will we have a little bit of the lineups that we used to have in oil crises?
Well, thanks for having me on. So, I think this is an evolution, right? And we've been on this journey for quite a while now, and technology and cars are coming along, and market adoption is starting to happen. So, this just doesn't happen overnight, where, now everyone's buying an electric car and all that infrastructure has to be out there. So there's a little bit of a buildup, and we've been going through that over the years. We started this adventure for Electrify Canada about 2.5 years ago, and are building out 32 stations. And really, what we're trying to go after is how do we drive that market adoption, right? How do we change that consumer behavior and the way they think about electric vehicles? And for us, providing the right type of infrastructure that drives confidence, right? That gives you that range confidence that you can go anywhere in an electric vehicle, just like you can in an ICE, is one of the key elements, right, to really drive that market adoption. So we've focused on building big stations, 4+ stalls at every location, so that when you do go there, there's available stalls that you're able to charge at, and also power, right? Not just power that cars can take today, but what's coming in the future. And so we've installed 150 kilowatt and 350 kilowatt charging stations. So with 150 kilowatts, that's about 120 kilometers in 10 minutes. At 350 kilowatts, that's somewhere in the range of 370 kilometers in 10 minutes. So, we're getting to speeds that aren't quite, what you would do at a regular gas station today, but they're pretty fast. And if the cars can take it, right, it meets the needs for a lot of consumers. So those cars aren't quite here in terms of mass adoption. The Porsche Taycan get to do 270 kilowatt charge rate. The Audi e-tron does 150 kilowatt charge rate. So, the technology is coming, right? So it's not that far in the future. More and more vehicles their battery packs are getting bigger, right? Density is increasing. So that allows more power to go into the battery. And then the charge acceptance is also improving. So charge rates are going up. So, consumers are going to want to expect that, right? They want to have speed. They don't want to have a car that are going to be tethered to a cable for hours to recharge. So putting out the right kind of infrastructure that drives that confidence is very important. And to your point on the peak days, there are going to be peak days, right? And it's how do you plan for those peak events, and what kind of stations. But as adoption happens, more and more locations are going to be installing this type of infrastructure. And so you're going to have choices in terms of where you charge, just like you have with regular petrol.
Thanks a lot. Just a quick question. Without revealing any state secrets for Electrify Canada, can you give us a rough approximation, just in say percentages or whatever, compared to today's number of stations? 10 years from now, how many, is it going to be twice as many stations with Electrify? Is it going to be 10 times as many? Any rough approximation of what your plans are to cope as we're going forward?
Yeah, so we kind of grow as the market grows, and we always try to stay ahead of the market to the extent we can. Right now, I think we're sort of building up and kind of playing catch up a bit, but our intent is always to stay with the market and ahead of it, so that again, it's always trying to drive that consumer confidence. So one of the things we've done is 32 stations, mainly covering main highways. Right, we just started our next round of investment. We're putting in about another 8 stations. And then we'll continue to invest as the years go forward, really building out, more destination routes, more metro locations, building more density in the metros, so we can start to service different types of customers, like people who live in multifamily homes that maybe don't have dedicated or overnight charging, but still need to be able to fuel for, just like anybody else would. So these fast fueling options are extremely important. And so both in the metro and in long distance travel.
Thanks a lot. Okay, Karim, a similar question for you, except that, of course, instead of asking about charging stations, will be up to the load. What about our electric grid? Hydro Quebec is Canada's leader in clean green energy, and a shining example for the rest of the country. In fact, a shining example for the rest of the continent. Will La Belle Province's infrastructure be up to the demands of having, say, 30 or 40% of the cars on the road being electric? What about 100%? And let's discuss peak loading, as I said. And if the worst day in Quebec isn't Labor Day, maybe we should be talking about what happens on les vacances de construction. You know what I'm saying?
Yes. Okay, good. So, David, thanks you for the kind invitation. So, first, I think the grid in Quebec, especially in Quebec, is very stable. And then we spoke about the lithium-ion battery, which is also, there are limitations on fast charge also. So I believe really difficult this kind of electric vehicle that can be fast charged about 5 minutes and less because of the chemistry and dendrite and so on. So if you go to the grid and so on, what happened, many of the people, they can charge in their home. And then when this kind of the peak powers and so on, what's the beauty on that, let's see, if you have in next few years, we can have like gasoline stations today that they are using, a big tank of gasoline that people are taking this gasoline and they can putting the fuel in the cars. That we can also think about energy storage, like large megawatt hour batteries, that this kind of large megawatt hour batteries, they can be connected directly to the charging stations, and large megawatt hour battery also can connect it to the grid, and we can charging them what the demand is very low, and it can be used this is DC charge. It's very, let's see, today we can see that iron phosphate chemistry is very cheap, can charge very fast also. So if you are putting this is in the interface between the grid and also the charging station, it's one of the solutions. And as you know today, just if I come back a little bit to explain the chemistry at very high levels, lithium-ion batteries would be stay for 100 years, over 100 years. And the chemistry is divided on LFP as technology and NMC and so on. And both of this technology will be also stable to be used in lithium-ion batteries. And the grid, I think, maybe in USA or other place with the grid is less, as I said, have less maintenance and is not in great shape. but there are not any issue about this kind of the vehicles and the charging in Quebec. Behind that, let's see, if you have like 1 million cars, okay, this is another way also to think about other application also. Let's see, every car has around 65 kilowatt hours. So we can have, it's a huge, about 0.65 terawatt hours. It's a huge energy and so on. So we need also to think about what we call it vehicle to grid and vehicle to home. And you become also one part of the grid, because let's see, except the vacation of constructions, I am working in my home and they have 65 kilowatt hours. So it can be used to the grid, or if you have your chalet, I don't know, in north of Quebec, and then you're going to use your car and so on to the grid and vehicle to home. So there are many things that you can adapt, because people, they said, oh, how about my cycle life? How about this is related to chemistry and also intelligence artificial, that you can make your algorithms to be see what you're going to make fast charge, low charge, and this technology. And of course, in the interface between the grid and between your home.
Thanks. I mean, the part that I found the most fascinating, what you're saying is roadside gas stations, instead of having underground gas tanks, could actually have an underground battery grid that stores the energy and then offers really fast DC to DC charging when the peak load is on. That sounds like a pretty cool solution.
That, David, is a great example of second life of battery use. That's one of the prime usage of a slightly degraded car battery that's no longer good enough for a car, but it's perfectly fine for a stationary application.
Well, if you're talking about burying like 1,000 Teslas under a gas station, I'm all with you. I'm all with you.
And
well, one of the things we've done, our sister company, Electrify America, that's also installed now 600 stations across the United States. At about 100 of those locations, we've put in battery storage alongside our DC fast chargers, and we do it for two reasons. One is, right, you pay a big demand cost when you put this large infrastructure out, so there's a big expense to operating these stations, and it depends on the utility and the tariff. So the demand charges really help, or the batteries really help lessen the peak, which then brings down the operational costs. But certainly, when in those grid peak moments, right, it allows us to offer the same level of service to the customer, right, without having to worry about, are we having a brownout or what's going on in the grid, right? So it levelizes the load, and again, the consumer doesn't have to worry about what time of day is it, can I charge now, can I not charge, right? And again, when you think about the consumer adoption, right, customers don't want to think about that, because they don't think about how they feel their car today, they just go and do it. And so we got to bring that same level of comfort and convenience so that they'll make the switch.
Thanks a lot. I'm probably going to end up talking to both of you more in depth about how that works, because that sounds like a great solution. Back to you this time, Olivier. As we've all said, it's quite a brave move. Very good for Volvo to go fully battery powered by 2030. The question is, are all consumers ready for this, for such a big disruption? Here in Canada, most of our EVs are sold in 3 provinces: British Columbia, Ontario, where I am, and Quebec, where Karim and Frederick are. In some provinces, and I'm talking about, say, Alberta, for instance, which is our oil-producing provinces, EV sales are almost non-existent. How does Volvo deal with that? How will your dealers deal with that? I mean, what's the process forward in the next 10 years to be very forward about convincing people who might be more reluctant?
Yes, and I think we have discussed about that a bit among us. This will be a gradually transition. It will be progressive. It cannot happen overnight. The more we make EV as easy and convenient, the more people will realize that they can live with a BEV on a daily basis. But obviously, you don't live and drive with a pure electric cars as you do with an internal combustion engine. And in our strategy and ambition, which is quite critical to us, both from a sustainability angle, but also for our future success. We also believe that governments will take the necessary actions to support that transition. And we have been discussing a bit about charging infrastructure. This is one of the key aspects supporting the transition, making sure that the expansion of the charging infrastructure will be faster, so to speak. But I mentioned that by 2030, we will only sell electric cars and fully electric cars, but by 2025, 50% of our sales, globally speaking, will be fully electric. The second half will be hybrids. So by educating customers, by actually bringing them, convenience, easiness, and the entire user experience around, again, the charging aspect, finding charging, access charging station, and so on and so forth. We think that more and more customers will realize that this is actually possible to live with an electric car.
Thanks. Okay. Thank you very much. Frederick, range anxiety remains, along with high cost, the number one issue keeping people out of electric cars. Right now, the solution seems to be bigger and more expensive batteries. Teslas have 100 kilowatt hours. I think Hummer's going to 200 kilowatt hours. But there's also a growing trend towards building in smaller batteries that can't travel as far, but they can be recharged more quickly. So what do you think is the future for cars? Is it big 100 kilowatt hour batteries and bigger? Or will we see, as some are predicting, a movement stressing lightweight and faster charging?
Well, what should happen, and I won't be very popular on that panel, is we should see less cars. That would be the ideal solutions before even talking about.
Oh, okay, well,
that's a whole different topic.
Panel yet?
I won't be very popular with that comment. I think people expect to have about the same range as they fill up currently with gasoline. So when you can hit the 400 or 500 kilometer range, no matter the size of the battery, whatever the trick the manufacturers are able to squeeze in, if you get about the same range as a fill up, it's enough for most people. The trend of smaller batteries with fast charge, I think, and that's just my personal opinion, I think that will be much more appealing to Europeans than North Americans. Although we don't travel that much, apart from you, David, we don't usually do Toronto, Montreal twice per week or things like that. So it's really wishful thinking that we need so much range. And when people really sit down and look at their real schedules and how much distance they need, I think same thing as a fill-up will be sufficient. All manufacturers seem to be able to do that type of range with the battery anywhere between 70 and 100 kilowatt hours. At some point, premium manufacturers, probably like Volvo, will offer much larger batteries, and very low-cost vehicles will offer less. But the concept of constantly fast charging to be able to do a long distance will get old very fast. You ride a motorcycle, David, how do you like it to stop every 150 kilometers for fuel? It's not super convenient.
No way.
Well, that's how most bikes are set up right now, with a 10 or 12 liter tank or something like that. Karim might have a different opinion.
Yeah, no different opinions. I can tell that the market will be segmented on three places. The first one is mass productions, less than $25,000. And this is using LFP chemistry that the range is less than 350 kilometers. And of course, you can make fast charge. The second segment of the market is about what we call it NMC 60%. And the range is around less than 450 kilometers. And then when you go to high nickel cathode materials, and of course is expensive, but I am thinking about all this technology are maybe less than $100 kilowatt hours on the pack. And then when you go to high nickel 80%, and this one, the range is higher than, let's see, 500, 600, 700 kilometers. And also this is what you can use SUV, van, semi-trailers, and also trucks, and so on. So this is the segment of the range, and being also on the cost and performances that will be divided in three.
Pretty much the way cars are divided right now, with bigger motors and more expensive and like that. Okay. Robert, I'm going to go back to you. And this is the one, you've already touched on this subject, This is the question that intrigues me the most. What's going to happen in 10 years in charging? Right now, 50 kilowatts is fairly common. As you mentioned, 150 is getting to be common as well. 250 is considered quite a bit. 270 is the most that any car currently available can handle. And you, as you said, you have 350 kilowatt chargers. Can we actually go higher than 350 kilowatt chargers? They're very expensive. They're difficult to build. I mean, and by 2030, could we get as high as 500 kilowatt charging points or more? What is there a limit? Is I guess what I'm saying, and how far we can go with this?
Well, it's all about the batteries, right? And what the battery could accept in terms of the limits. I mean, the power electronics, right? We have the technology today to be able to do this. So from a power electronic standpoint, that isn't so much an issue. I can say already, we're going to see cars in the very near future that are going to be 300 plus 350 kilowatts of power. These are passenger vehicles and capable of doing that, right? So, you know, the price of batteries coming down, they put more battery in the car, which means a bigger battery pack. So it's a bigger class, you can fill it faster. So that way charge rates go up. And so you're going to start to see, and the density and the charge acceptance is getting better, like I said. So that is going to drive higher and higher charging levels. I think already on the heavy duty side and medium duty vehicles, buses and those type of applications, they're already talking about megawatt charging rate. So you know, that is certainly already here. So it's just a matter of time, and those are large battery packs, right? So they can take a lot of energy at once. So, you know, as the technology gets better, you're going to see that number being pushed and more. Obviously, that has effects, right? What does that mean to the grid? How do you manage that? How do you provide that appropriate power? And if we get to, you know, 1 million vehicles or 100% adoption or thereabouts, that's a lot of power on the grid. So things around what we do at the site in terms of combining with energy storage, managing that load we're putting on to refill cars, but still give consumers what they expect, right? And that's be able to drive their car anywhere, charge as fast as they can, and get them on their way any time of the day.
Thanks. Karim, you've already talked a little bit about battery technologies. Right now, various forms of lithium ion are the norm. Is there anything beyond lithium ion? People talk about solid state batteries. People talk about lithium air batteries. In the next 10 years, are we still going to meet in 2030 talking about lithium ion, or will something else have taken over in 2030, do you think?
Yes, it's great questions. If we see our periodic table as electrochemists, you can see the light element in our Earth is lithium. And the radius of lithium is the smallest one for intercalation compound. So it will be very difficult to see behind lithium chemistry. And then lithium ion will be dominate for next, as I said, over 100 years. And solid state battery with lithium, of course, what we call it solid state because electrolyte is solid and we can have lithium metal and the energy density will be increasing. So solid state, they will come as a niche market. And behind that, I think Frederick was explaining very well about hydrogen. So we're going to see the coexistence between hydrogen and the battery because hydrogen is energy generators and the battery are powers. But they're not, this kind of fuel cell and battery is not for, as I said, mass production car. It's impossible. It can be for semi-trucks or long distance, train, aeroplane, and so on. We saw that. So there will be coming the solid state battery, but maybe over 30, because there are many issues to be resolved in this solid state battery. But there will be many improvements for lithium ion batteries, for the chemistry to enhance the voltage, to enhance also, as I said, this kind of fast charge is big problem with lithium ion today. Because as you know, you can have fast charge, but if you the lithium, before it's going to be intercalated for as far as it can be making depositions and become dendrite. and this don't drive can go through the separators and they can cause fire and so on. So there will be a lot of engineering and a lot of way to going on lithium ion by one to reduce the cost of lithium ion battery, increasing the performances, increasing the safety. So there will be, as I said, over 20, 30, three technologies coexisting together, segment the market, lithium ion, advanced lithium ion battery, lithium solid state battery, and hydrogen.
Well, it's going to be complicated. Okay, we've geeked out and we're doing much technical stuff. I have a marketing question for Olivier, and that's basically with sustainability comes a little bit of social responsibility as well. And one of the things that surprised me was a study out of University of California, was that 90% of American EVs were bought by men. We're not that much better here in Canada, even though we like to congratulate ourselves. I think we're at 82% male buying. How do you, again, from a marketing standpoint, how do you get women to consider EVs? After all, by some estimates, they buy more than 50% of all the cars. And so it seems we're losing a little bit of an audience where we're not getting enough women interested in electric vehicles.
Was not aware of these figures you mentioned from a Canada standpoint. I can only comment from a global perspective, but we are, per definition, at Volvo Cars, a human-centric company. So everything we do is based on the human per se, independently of gender. And the way we address the user experience, the way we see how pure electric cars should be as convenient and as easy as an internal combustion engine does not come with any gender differentiation. This is very important to us. I'm sure you know, of course, about our safety. And you might know or not know, but we have actually a project when it comes to safety that reflect that quite well. I believe this is equal safety for all. And we have been looking at safety for decades and years in the same way, no matter the gender you are. We are literally looking at human-centric, and everything we do is human-centric. So we don't see any difference here on our side.
So, in other words, I think what you said is that your safety studies are very much considering the female owner, so that it's all that vaunted Volvo safety is applied to absolutely everyone. And you think that's going to be a market differentiator that will get women into your EVs?
Again, if I would say, without going into gender differentiation, when people will understand our approach, making your life with an electric vehicle as easy and convenient as possible, why would the man and the woman have a different understanding and a different pain points when it comes to an electric car? I mean, it should be convenient to everyone, to the family. And you should be confident to live with your electric car, all day long distance trip, daily commutes, no matter you are a woman, you are a man, it doesn't matter.
Absolutely. Completely agree. Frederick, technical question, and try not to lose me with my grade 8 physics, right? The two subjects that always come up when someone is discussing electric cars are the two we've been talking about, batteries and charging. We never hear anything about motors. We never hear anything about transmissions and the other things that make an EV well electric. So as I say, without befuddling us all, what other areas of the EV should we be thinking about? Are multi-speed gearbox like in Porsche's new Taycan worth and being engineered into more cars? Is there a difference between electric motors? Is there room for efficiency in other areas besides just what we always talk about, which is again batteries and charging?
Yeah, well, first of all, David, people have to know that you are an engineer, so don't pretend you don't know anything. You're not just a journalist. The other areas of the car, honestly, they got them pretty spot on from the first go. So improvement has not been as drastic on motors and controllers that what we see on batteries. That's why people don't really think about it. The race right now is to reduce production costs. Efficiency, of course, we still try to climb, but when you're already at 94, 95, 96% efficiency, that little 1% incremental change will not give you much more range. Where those incremental efficiency improvement help you is less thermal rejection, so less cooling systems. So it is important, but not that much. You don't gain a lot of range. It's really on production cost. If you look at the Model 3, it has a very innovative motor. It's a switched reluctance motor with some cheap magnets inserted in it, not fancy magnets. So they managed to make a motor that to the drivers feels very linear. It feels very natural to drive, but it's a super cheap motor to produce and has tons of power. So we don't realize it, but to be able to afford such a huge battery, Tesla has to cut corners elsewhere, and they do it by being smart. That's one of the things they've done. The switches in all the power electronic, either the chargers or the traction controllers, the switches are improving also. There's new technology in there, silicon carbide FETs. I don't want to go into the details, but it's improving basically to have them lower cost. You were asking about multi-speed. I think that electric vehicle right now have too much performance already. Putting multi-speed for higher top speeds or higher gradability is not going to be the way to go. In trucks, it's a whole different thing, but not for passenger cars. In fact, I'm even surprised by the trend. Why are cars like the Bolt or like regular cars, why do they have so much power? I mean, we rent French shit boxes when we go in Europe, and we still manage to get a speeding ticket with a 50 horsepower car. So our needs of power are way overserved currently by the market. And at some point, EVs will become more reasonable also on that field.
I got to disagree with you. I got to disagree with you. There's never such thing as too much performance. I'm sorry. I'm sorry. I'm sorry. Okay, continue, please.
I drove a Prius for 11 years. So for me, everything feels fast right now.
Thank God there's Taycans. Thank God there's Taycans. Robert, payments and costing going forward. Right now, electricity is cheaper than gasoline. Also, there's also a bit of convenience, the talk of convenience with charging cars. I mean, right now, I believe Electrify Canada has a system where you can pay for on your credit card. There's a cheaper method with a membership. So going forward, are you pushing more subscription? The other thing is and we had a reader write in and say, like, are we going to always be charged on the number of hours of charge that we're doing, or we're doing by being charged by kilowatt hours? And it seems quite a few knowledgeable EVers are concerned about the cost going forward, that it might increase as there are more EVs on the road.
Yeah, so in terms of just general cost, right, that's something we're very sensitive to, because, right, that's another sort of hurdle around consumer adoption. Is, okay, well, in that consumer psyche, it's like, okay, where do I charge, and now how much is it going to cost me to charge, right? And they're always going to be comparing you against petrol. And so we take that into account, and at least, we try to stay competitive, so that we're fair to customers. But the nice thing about electric vehicles is, for the most part, people have choice, right? You can charge at home, potentially at work, or on the road, right, in terms of fast charging. So it's, in terms of customer satisfaction, right, you have options. And so that leads to a lot of positives overall. In terms of how, the unit of measure we can bill by, we completely agree. We think we should bill by kilowatt hour. Exactly what you get is what you should pay for. But that's governed by regulations, right? And so right now, it's not really allowed across Canada. So we've stayed on a per minute basis, but there's work ongoing to change that. And so hopefully in the near future, we'll see that to happen. On the US side, it same issue. And it's state by state dependent. And where we can, actually, in Electrify America, we do charge by kilowatt hour. So as those rules are updated, we'll be sure to follow that and be able to switch. And then, we think the network and the charging should be open for everyone, and it should be no different than how you charge for your gas card today. So when you pull up to one of our stations, there's a credit card terminal. Just swipe your card and pay. If you want to join membership and get other features in terms of real-time status and other notifications of is the charger open and other neat features that can help you make decisions about how and when you charge, then if you join the network, then certainly you can get certain benefits, just like any other membership club, where you get certain points or things like that for using that store or that brand, right? And so that's just another way we engage with customers and help monetize and make the network sustainable.
Well, that's good news, because I'll be honest with you, one of the problems that I ran into testing electric cars is going to charging stations that were told, where I thought there'd be easy charging, and you had to have membership to be able to access it. The fact that I could use a credit card at Electrify Canada, I mean, that's good news, and it's a good business model going forward. Okay, I'm going to ask some questions that are based on, some of them based on readers. One of the questions that people are asking is, how long will it be before we see cars with, say, 400-kilometer ranges that can be recharged in 10 minutes? And I actually should be more than 400 kilometers, because you only charge 80% of the battery. How long till we can see cars and infrastructure that will allow us to stop somewhere, recharge 400 kilometers in 10 minutes? You know what? This is for everybody. Olivier, do you have any idea when Volvo expects this to happen?
I think this is an interesting question, and global outlook on this question on our side is this is less and less range anxiety. This is more and more charging anxiety. So you can, of course, debate on where should be the range, but I think when, as you said, Robert, when you will be able to drive to any charging station, as you are used to drive to any gas station, charge with your credit card, I don't think you will foresee or see the charging anxiety the same way you might still see it today when you portray yourself owning a full electric car. So I would rather bring that back to the charging anxiety, and how can we remove this anxiety moving forward?
Actually, so I'll go with you, Karim, next. And by the way, guys, the 10-minute number was the most common number that I've had from readers. Like, that's the demarcation. They don't need to get to the 5 minutes that gasoline can do, but 10 minutes, that's when they'll start considering, mass adoption. So can we get 400 kilometers in 10 minutes in the next 10 years, do you think, Karim?
Yes, in next 10 years, I believe so, yes. As you know, if we are changing this chemistry of graphite, silicon, or alloys, or something of anode materials, it be possible. Maybe it cannot at 100% fully, but around 80-90% of DOD of SOC, it will be possible. So the chemistry, working on the chemistry, especially of anode materials, which is today the issue to be resolved. So I said, yes, it's possible next 10 years.
Thanks very much. Fred, what do you think? I mean, you work with batteries and charging infrastructures both. Do we get 10-minute charging in the near future?
Yeah, in engineering terms, it's a 6C charge rate. This is possible right now with a lot of the chemistries out there. Even with LFP, which is a low-cost, fairly common chemistry, you can do 6C with a properly constructed cell. The hit will be energy density. So how much will that pack weight? On heavy-duty vehicles, it's less of an issue. And there's even fancier chemistries with LTO anodes that can do it easily today. They can charge in 1 minute. I think Karim even had a cell that they broke the cell cycler before the cell broke. Gives you an idea of how good those are. But the energy density is not there. So in the auto business, you have to have a balance. You need range and speed. So right now, the balance seems to be with NMC. and a 6C charge rate sustained up to 100%, I don't think we will see that in the next couple of years. But there's some engineering tricks that can help, and some cars already implemented that. Again, I'm taking the Tesla example, but I'm really not a Tesla fan. It's just that instead of talking about their ideas, they actually put them in cars. So it's kind of nice to see how it works in the real world. If you show up to a supercharger station and you plug it in, you will get a bit less power than if you typed in a supercharger destination in your nav screen before you went, because the car is going to pre-chill the battery. It knows you'll go to a supercharger and it will pre-condition thermally the battery to accept a bit of a higher charge. So there are tons of little tricks, of engineering tricks that we can implement. Maybe it will rely a bit on the user doing specific things like this example, but yeah, 6C will be possible. Is it in the next 10 years, maybe in the last part of that decade period? But currently it's already doable. If you are ready to pay the expense of energy density, it's totally doable today.
Thanks. Robert, will our Canadian infrastructure, our charging stations, be ready for that kind of demand? I mean, is it possible to get 80% battery charge in 10 minutes going forward by say 2030?
Oh, absolutely. I think so. I think we've discussed several of the ideas of how to manage in terms of the heavy output, right? With incorporating battery storage at the locations with the DC fast chargers. So yeah, I don't think that there'll be much of an issue. There's still a lot of build out and a lot of infrastructure improvement. So obviously from a grid perspective, will have to be some work, but that happens over time as the industry grows as well, and as this demand is planned out from the different infrastructure companies putting out their equipment. So and then as time moves on, battery capabilities get better for cars, but guess what? They get better for stationary storage as well, right? And so the cost of that stationary storage comes down. So it's a win-win for everybody. When we get the economies of scale with electrification of transportation, and so you'll see more and more of that infrastructure being installed. And I think surely within the next 5 years, to go to 80% in 10 minutes. I think we're on the cusp of that, and we're already starting to see that in some vehicles. And as Frederick said, right, car companies are already understanding how to get things to work so that you can get there. And the technology, like I said, it's going to improve. And so that's why we're putting out the 350 kilowatt chargers today, because we know it's just around the corner. It's going to happen.
Well, this is all good news, man. I'm learning a lot. And as Frederick said, I have an engineering degree, but I'm being schooled here right now. Now we're going to move to some questions from readers. And I've got to tell you, some of them are fairly insightful. For instance, Jonathan asks, what are the chances we will be able to buy longer replacement batteries for our current EVs? I think he means the upgrades. He's not the only one wondering. Peter asked, how feasible is it that battery packs be incorporated to be upgraded in the future as battery technology improves? Olivier, is this something that that Volvo is going to look into as it moves to its 2030 destination?
Interesting thing, I believe, with electric cars, and what we have been doing actually a couple of weeks ago is you can already improve several things via over-the-air updates. And we started to roll out those first updates to our XC40 pure electric. And basically, you can already improve the charging speed, and you can already improve the range. So to me, this is not only looking at the hardware, but this is a combination of hardware and software. And pure electric cars unlock also lots of possibilities, and we are going to leverage that more and more via over-the-air updates, where we can enhance the experience over time. So that is a slightly different view to look at it, so to speak.
Thank you very much. Karim, I have to say, and I think we mentioned this before, your reputation precedes you. It's the first time I've had viewers asking to talk specifically to one particular panelist. So we're thrilled to have you on. Unfortunately, they were asking questions that would lose the rest of us, so we're not going to go there. However, believe it or not, Deputy Director of the Department of Natural Resources Canada wants to know if hydrogen fuel cell road vehicles stand a chance of competing economically with battery-powered EVs in the coming decade. I think we've covered that with cars, but what do you think about long-haul trucks? Is that something that fuel cells can compete with batteries, or will they actually dominate batteries, or will it be the other way around?
I believe I know recently that Daimler, Mercedes-Benz, and Volvo, they make a joint venture on these trucks for we're using fuel cell and so on. I don't think so that there be competition between battery and fuel cells. Battery and fuel cell are complementary. So we need fuel cell and we need batteries in the same kind of this kind of long range. And I believe we need fuel cell for this kind of the technology. And for acceleration, we need the battery, lithium-ion battery with low cost. So for this kind of applications, I think we need the hydrogen, and it can be also fast charge, because when you fuel your trucks, it can be like few minutes and so on. So for me, I think because energy density like that today about the cells, we're going to go to 300 watt-hour by kilograms, and maybe next 5-6 years, only 400 watt-hour by kilograms. You cannot bring 1 tons of the battery in your trucks. So it cannot mean that we need, but so fuel cell, I think the best solution for this kind of applications.
Yeah, I'm guessing Nikola Tesla and everybody is the truck company that GM bought is happy to hear that, because batteries. I remember when batteries had were equal in 20 years ago in technology and advancements compared to hydrogen fuel cell, and batteries took over, whether that's the popularity of Tesla or an actual technological advantages. It's tough to say, but it's good to hear that there'll be something useful out of all the technology that companies like Ballard have done. Frederick, I've got a question for you from a gentleman named Vaughn. He's the CEO of a chain of dealerships in our Western provinces. And he asks, how will we properly transition, particularly in the bitterly cold West, where we are the last adopters? Fred, I've been to your offices in the winter. I think you know something about cold weather in this question.
If you look at the adoption rate of EVs in Texas, which is a oil-producing place similar to Alberta, it's been surprisingly high. I think the Albertans are very, very pragmatic people. Whenever that type of vehicle will fit their needs and whenever it will be cheaper to operate, they will do the switch. For that technology to work, though, well, climate is a big issue. Contrarily to what most people think, the efficiency or the range that the battery gives you in cold weather is not that much diminished. It is, but not by that much. Why do you have less range in colder weather? It's basically because you heat the cabin like crazy, so you take a lot of energy to heat the cabin. And then it's slush and snow and tire resistance, and the air is a bit denser to go through, but most of it is in the heat of the cabin. But in a properly constructed vehicle that is well insulated, that runs a heat pump, that has heated seats, heated steering wheels, all these little things add up to lessen the impact of cold weather. As vehicles get bigger and bigger and bigger batteries, we're talking about 100 kilowatt hour batteries, the impact of that cabin heating gets less. In an original Leaf that had a very poor range, well, then it was huge. You lost half of your range. But that same amount of energy on a 100 kilowatt hour battery is a lot less. So I think that problem will be solved by itself. Don't fear people out west where it's cold even longer than in Quebec. As batteries grow in car, the impact will be less. Think of it exactly as the same impact on your gas-powered car right now. You lose range, you lose efficiency in the winter, but it's like what, 15, 20, 25%. You don't double your fuel consumption in the winter compared to summer. So you'll have about the same impact on your range. I don't think in the long run, it's going to be much of an issue.
Okay, thanks very much. This one, I'm going to go back to Olivier. going forward, say in 2030 again, what technology is going to be offering the greatest competition for your fully battery-powered vehicles? Do you see internal combustion technology resisting the change to fully BEVs? Do you see most of the competition for your battery-powered vehicles from, say, plug-in hybrids? Obviously, it's not going to be hydrogen. Where is the competition? What do you have to compare yourself against as you move forward technology-wise?
Yes, and from our standpoint, the move to becoming a full electric car manufacturer by 2030, this is not only from a sustainability angle, as I mentioned, which is as important to us as safety. This is also because we believe that we don't see a long-term future for internal combustion engine. That is our belief. So instead of investing into a shrinking business, because we need to keep growing and to stay profitable, we believe that we should invest in the future. And by that, I mean going full electric by 2030. So this is our strong belief. And we want to accelerate, of course, the transition to zero emission mobility. And we want to be leading also the transition when it comes to our industry. So we contemplate it from that angle. The internal combustion engine for us with business and on the long term.
Thanks very much. Okay, we're getting down literally to the last question. It's going to be for Robert. Thinking of all the technologies you've discussed for infrastructure and the various battery powered cars where we've talked about, what is your biggest concern between now and 2030 for building an infrastructure and having more EVs on the road? Is it government funding for infrastructure? What is the biggest challenge that Electrify Canada has going for the next 10 years?
So our biggest challenge, and I think we face it today, is really getting the system up and running, right? In terms of everything that goes into building that infrastructure, right? So us from an equipment and construction standpoint, I think we have that handled, and we know how to do that. We know how to do it very efficiently. What doesn't know how to handle this type of infrastructure are the utilities, and at the rate that we want to build that, they can't keep up with us. So we've built stations that have sat on that are fully constructed, ready to go, but have been sitting there for sometimes up to 12 months, waiting for the utility to come bring their transformers to come do their work, and the level of work they have to do isn't that much. But utilities, when they look at new service, typically they're looking at, okay, here's a developer, they want to put in this big building that's going to take 12, 24 months to build. And so they work on those sort of timelines. And this is very different, where we're going into a parking lot saying, I'm going to put a megawatt load here in this corner of the parking lot, and I need to do this quick. I need this done. I'm going to be done in 6 months. Let's go. And so that's kind of a big shift for them in how they think about this and their processes and everything else. So that to us is going to be, I think, a big thing that has to change in the industry to be able to keep up with all this infrastructure that needs to be built out. Because again, we're trying to stay ahead of the curve as this adoption happens. And while we haven't seen that many, we've seen some vehicles. Now we're seeing a lot of different vehicles coming out, a lot of different makes and models that appeal to a wider customer base. And so we're going to see more and more consumers adopting those vehicles. And so we need to make sure we stay ahead with that infrastructure coming out. And so we're reaching this inflection point that it is going to go up faster and faster. And so we need all the participants to sort of get on board and help those like us that are putting private dollars in to build that infrastructure to do it quickly and keep up with us. And so it's a little bit different mindset. It's a bit of a challenge, but those processes and the skill set and just how they deal with this problem of electrification is going to have to change.
Wow. What an interesting discussion. I've got to say, I've come, in an hour, just listening to you guys, I'm become more optimistic about the future. And God, I'm something of an EV skeptic. So, excellent. Thank you very much. Unfortunately, we are used up all our time. So first off, I want to thank everybody who tuned in. You, the viewers, are what make driving into the future successful. And as always, I want to thank our wonderful guests. To Olivier, I say thank you for making time at a time. I think it's the end of your day, actually. Robert, thanks for so many insights into one of the most important industries for the next decade. Frederick, a pleasure as always. And Karim, it's absolutely incredible to speak with you. Hopefully we can do it again. Thank you all again. And thank you to everyone who listened in.